Our next speaker is Gorazd Bregar. Gorazd is the founder and CEO of CALMS. Please join me in welcoming Gorazd.
Thank you, Kimberly, for introduction. Hello, everyone. I'm Gorazd from CALMS. In case you wonder what CALMS stands for, the meaning is keep calm. You know that, no worries. So CALMS will take care for your compressed air, and of course also free from wind. So this means no air leaking. Okay, but seriously, CALMS is compressed air management system, and today I will try briefly introduce a little bit advanced top remote monitoring, which actually is not monitoring, but we are using term management because it's a little bit higher meaning, and we will focus on management, on controlling of air quality with the use of auto analyzers, and in the end I will also introduce some interesting findings based on correlation analysis. Okay. So a little bit about myself. I work for over 30 years with the compressed air. I'm the team leader of CALMS. We are independent, let's say, compressed air enthusiasts, working for since 2008 as a compressed air experts and software developers for 15 years, trying to create independent global management software platform for with a holistical approach, action-driven, and with the engagement of all users implemented in this process. We have offices in US, Slovenia, and Sweden, and covering more than 1,000 systems worldwide. So the first important thing is to differentiate between management and monitoring. Energy management system is a little bit higher and includes also monitoring part, and it is proactive approach. We also use holistic approach so that it's included everything from asset management, assessment, system review, audits, permanent monitoring. So everything that is focused for finding the opportunities with the savings action cards. With the monitoring, we are just trending, collecting data, analyzing data, but we don't have any, we don't address the real root cause for energy inefficiency. So actually you need an expert to help you verify and analyze the data further. So compressed air management should include data acquisition, monitoring, collecting data. It will provide energy analytics and insights to the data. It will give you tools for energy optimization, simulations, events tracking, carbon tracking, before after events, cost management, purchasing management, and asset management. So on the right side, you can see a lot of detailed elements which are part of every compressed air management system. So why we are using auto analyzers and why we are using also artificial intelligence, how we incorporate this into the auto analyzers. When we are collecting data, we are talking about huge or big data. So we are collecting data with a sample rate of 1 second, 5 seconds sample rate. So this means that for one, let's say, medium system, compressed air system, we are measuring about 20 to 30 channels. And additional, we are calculating another 20 calculations. So we have 50 channels, and human cannot process more than 1 hour of such data for maximum 5 channels on your left. On your right, you see what computer can do. They can do with the auto analyzers, they can analyze 1 year of data, 5-second sample rate, more than 50 channels, and give you opportunity cards. You can focus with the experts to detailed analysis of this data. So below you can see, today I will focus on air quality. And last week I was at one of our customer in copper mine working as an auditor. After 1 year, they start repairing the pipings. They're a big copper mine, so they're using a big centrifugal compressors. The intake air is very dusty. So this dust is coming also, if they have absolute filters, they come to the impeller side, to the intake of the compressor, which you see is dirt. And this goes then to air dryers and further with the old pipings to the system. When they cut the pipes, they found a lot of dirt inside. So we were measuring during the audit dew point and temperature and flow and pressure drop over the dryers. So those are the typical measurements that we do when we track the air quality. When we collect all this data with the sensors in the factories in different parts, the process is with the edge devices or loggers. We collect those data. We transmit this data immediately through 3G or 4G or 5G as a data stream to the servers. So that is the meaning of remote, where we have the auto analyzers charting. And together with the help of independent experts, we can validate those data, we can analyze the charts, and also independent experts can also help with their knowledge to create new auto analyzers, to do the simulations, find the best actions, and then the actions are giving us the savings, which are actually needed in the end solution of the management. This is a little bit detailed process where we have a compressed air system with the compressors, where we always measure the electrical input power. We measure on a wet side pressure, sometimes the temperature, then we have air treatment. And after the air treatment downstream, we measure dew point, pressure, temperature, and flow. So those are the most important measurements that we do with remote monitoring. Those data are collected from different factories, different zones. Also the waste management through the assessment, they are collected in the servers. With the auto analyzers, we can have different views for multi-site view, for KPI, benchmarking, comparing different systems based on isentropic efficiency. And then we have a plant single system view, like a SCADA, for supervision and operational on a single plant. And then we have an expert view with all the tools needed for compressed air experts to validate, analyze, simulate using MT diagrams, QSON diagrams, and all that correlation tools for analyzing of the data. This is the complete process for compressed air management. And the results out of this compressed air management, out of these auto analyzers, are opportunity cards. We are collecting opportunity cards automatically. They are created in 5 different segments. The first one is coming from system assessment, which can be a system review or pre-audit or waste survey. Then we have the cards that are coming out of training, which is a very important part. When you do the training, you get the questions and also pop up the cards. Then we have audit, energy audit, where an expert is doing based on the measurements, creating the cards with the savings opportunity. We have the permanent ongoing monitoring, the fourth stage, and the last one is the asset management, where we collect all the cards. And for example, this is change dryer type. And the card will actually give you the solution what to do in the compressed air to make it work better. It will be equipped with reliability score, number of hours of potential problems. This is based on AI algorithms. It's calculated in a lot of systems, and we are training this model continuously. Then we have financial score, how much savings in dollars you can get in your system, and sustainability score, how much CO2 you are actually saving if you are to this opportunity card action. So to finish this comparison between monitoring and management, based on monitoring, you are getting different charts, different trends. And based on these trends, you can trigger, can have a threshold for a dew point. For example, here, you will trigger an alert, alarm, or warning. And then you need to call some expert to take care and look for all the data and give you the solution for this. With the auto analyzer, when you are talking about the compressed air management, auto analyzers are a little bit advanced tools with algorithms that will create action. For example, here in this picture, you see a very dirty compressed air and clogging the sensor, and auto analyzer calculated the difference between calculated flow, measured flow, and pop-up alert, which says that you need to check flow sensor because of the drift. Verify, calibrate, clean, or do some other inspection. So this is some example of this. We can use the tools like correlation tools together with auto analyzers to go a little bit deeper. For example, in this case, we were measuring dew points in 2 different locations, and we were not able to find out the root cause for the problem of a high dew point at point number 1. And with these 2D charts, correlation charts, we actually see a different combination of the compressors, like the blue one, which has a very high dew point, but we didn't know when this happened. And in 3D chart, we were using 2 different dew points and together with the system flow and the combination of different compressors, and we were able to see exactly where those combination is coming from, related also to the flow and one of the compressor which is operating in 45% of the time. The last part is actually okay, just skip it. Is actually maintenance and total cost of ownership, which is a very important part of complete compressed air management. With the maintenance logs, we should not log only the compressor service intervals, but also dryers, filters, instrumentation, receivers. Everything should be tracked and logged for the servicing, because service is a very important part. And the total cost of ownership is the next element, which is very important for the complete management. It calculates the cost of your compressed air, your dryers, filters over 1 year, 5 years, or 10 years. So this is everything as a complete compressed air management. Thank you.
Now we will transition to the Q&A section of the webinar. We'll have roughly 10 minutes, so we'll try to be as efficient as possible in answering everyone's questions. If you would like additional details on the topic, please submit the request in the questions window, and we can reach out following the webinar. This next question is for you, Gorazd. This one came from Evan. And this is specific to your system, can the CALMS system connect to a plant's existing distributed control system? Can the data be read by an external controller? For example, if the customer already has an existing control screen they use on their own DCS?
Yes, it can. CALMS is very open, so we actually support with the protocols any existing system. We are supporting out of the box many compressor controllers. If you have a special PLC, we can create a Modbus communication, Profibus communication protocol, or ADS, or Profinet, EtherCAT, or whatever protocol you have. So actually, it's very open. The idea of CALMS was to create the system that would have a predefined sensors with predefined addresses. You just select and use it. If it's not there, we can add it. If you have special requirements with the existing PLC, we can connect to with a configurable data configuration data set. So yes, no problem.
This next question is for Gorazd. This is also specific to the CALMS software. This one came from Eric. Will the CALMS software always define the best compressor configuration versus end user demand, like pressure and flow? How often does the software optimize the compressor configuration?
Okay, so CALMS software for management can use the tool, the simulation tool, and they, based on the huge database of the compressors, complete KGI database, and a lot of compressor manufacturers and other compressors are in the database. So you can actually compare based on the flow profile, pressure profile, the best combination of the compressor for existing system. This is done based on simulation. So for a particular reporting period, maybe 1 week, 1 month, 2 months, or 1 year. This is, but this is just the monitoring management. This is not the controlling part. So from optimization down to the controls is another step. They are not connected all together because of the safety and all the issues. So the combination can be selected, yes, best we can provide with the data.
Okay, thank you very much.